Welcome to Efficient V's short technology presentation of a 3D printed 120-degree V-twin. Efficient V's geometry-driven straight line reciprocation offers several advantages, including reduced friction and wear, more power, increased durability, improved piston dwell, and reduced vibration. The 3D printed model is half scale, but the full-size model is a 939 cc 120-degree V-twin with a 3.2-inch bore and a 3.5-inch stroke. So we thought a quick review of the geometry at work here would be useful. The cylinder bank angle is represented as V in this diagram, and the crank pin angle about the central axis of the drive pin is required to be twice the cylinder bank angle of 2V. The crank pin distance from the drive pin central axis is 1/4 the stroke, and the ring and pinion diameters are equal to half the stroke and the stroke respectively. The ring and pinions are situated in each end of the block on each end of the crankshaft.
This is Efficient V's 3D printed half-scale model of a 939 cc 120-degree V-twin. Efficient V is scalable and can be configured in different cylinder bank angles and numbers of cylinders, including V4 or radial. Efficient V offers a geometry-driven straight line reciprocation mechanism. Let's talk about why this is important. Conventional piston engines are limited by the crank rod slider geometry. As the piston reciprocates in the cylinder, the angular geometry of the connecting rod causes eccentric forces and thrusts the piston into the cylinder wall. This produces the majority of friction present in a conventional piston engine, causing excessive wear on the skirt, piston, cylinder, and rings. Note that this used piston is no longer serviceable due to this type of wear. Efficient V does not have this geometry limitation. Efficient V has geometry-driven straight line reciprocation. As you can see when I reciprocate this, the Efficient V crankshaft orbits in a planetary fashion, converting reciprocation to rotation in a smooth, harmonious manner.
This is a section through the first cylinder illustrating the relationship between the piston, cylinder, and crank pin. There are drillings not shown here through the narrowed elongate section of the block to deliver oil to the elongate section of the piston, which in turn delivers oil to the crank pin through drillings in the piston. A Fortune 500 company studied Efficient V and determined there would be a 3 to 7% performance gain in their application, mostly due to reduction in friction between the piston and cylinder. This is an example of cylinder failure due to piston rub and rock at the top of the cylinder in a conventional aircraft engine design. In this example, Efficient V piston travel is plotted against a Ford V8 of 3-inch stroke, and it may be seen that dwell is dramatically improved over the conventional example, and the piston acceleration and deceleration is much less, reducing friction and travel. Efficient V has more dwell for extraction of combustion energy for conversion to work and lower friction in operation. Please share. We are seeking opportunities to apply our exciting new technology. Thank you from our team. We hope you enjoyed it.